Okay, so you've memorized the alkene addition reactions, and you're trying to apply them to these different alkenes in these exercises. So you would look at the alkene, you'd say, oh, I have that extra pi bond, so I can use that as molecular glue to add things onto this molecule. So we're doing addition reactions. What type of addition? That's where you would look at the other reagents, and because you have studied them and learned them, you would see that Br2 and you would say, oh, this is halogenation. So I'm going to be adding 2 halogens. And you sort of want to think of what are you adding, where are you adding it, and what direction is it being added from. So how are you adding it? So in the case of halogenation, you're adding both of the halogens in the diatomic molecule that you're given. It won't always be bromine, it could be chlorine or it could be iodine, but whatever halogen you have, you'll be adding 2 of those. So we'll be adding 2 bromines. Where are you adding them? There's no rearrangement here, and so you're going to be adding them both onto the atoms in the double bond. So wherever the double bond is, those 2 carbons are where you're going to be adding the bromine. And because they're both the same atom, it doesn't matter where one goes or the other goes. And then how do you add them? If you look at the notes for this on the reaction list, you'll see that it adds anti. That means one is going to be coming towards you, and the other is going to be going away from you. So they're going to add on opposite directions from each other. And then if you have a chiral center, just make sure that you have a racemic mixture. So a 50-50 mixture of the 2 enantiomers. So those things being given, you can take this molecule and you can say, okay, here are my 2 atoms in the double bond. I'm going to add a bromine onto each of them. There's no rearrangement, so I don't have to worry about that. In the process of doing that, we're going to use up those pi electrons. We're going to use it as glue to stick these things onto the molecule. And if we had no chiral centers, we would essentially be done. But we do have a chiral center here. It's going to develop here. And so you want to make sure you have both enantiomers. So in one case, you would have this bromine adding towards you, and the other bromine would be going away from you. That would be one of your enantiomers. And then in the other case, it would be switched. So this bromine would be going away from you, and this one would be coming towards you. Now, because the top carbon is not chiral, you really don't have to put the solid wedges or dash wedges to that top carbon. So that's just extra information. But just so you can see that they're anti, I'm going to include that in this video. What is very important, what is essential, is that you have both of the enantiomers at the chiral center. So those are your 2 products for this particular reaction. Okay. Let's try that same thought process with another reaction. So you'd look at this reaction, you'd see the double bond, you'd say, okay, we're doing addition. What am I adding? You'd see the 2 halogens, and you'd say, we're doing halogenation. So we're going to add, in this case, 2 bromines, because that's what they give us. But if it was Cl2, we would be adding 2 chlorines. And where are we going to add those? Since there's no rearrangement, they will be added on the 2 carbons in the double bond. Now this is a ring, and so it's very important that you show that the bromines are on opposite sides of the ring. And so one bromine will come towards you, and the other bromine will go away from you. And in the process of adding them, you'll get rid of that pi bond. But because we have chiral centers, we have to draw both enantiomers. We have to have a 50-50 mixture of the 2 enantiomers. So to get the other enantiomer, you switch these. A very common question is, how do you know which one is coming out at you and which one's going away? And the answer is, if you have to draw that, you're going to get both. So both bromines will come out at you, both bromines will go away from you. And in these products, they'll switch in the 2 enantiomers. The last thing you'd have to do here is you'd have to adjust this methyl group. So because this carbon here is tetrahedral, it should have 2 bonds in the plane, one coming out at you and one going away. And so if this one here is just missing the one coming out at us, then that's how we'll draw that methyl group. And if in the other molecule the one is just missing one going away, that's how we'll draw that methyl group. And so those would be your two products for this bromination reaction. So hopefully that gives you some sense of how you would approach these one-step synthesis problems with halogenation when all the reagents are given to you.